Morning guys, today we're going to learn how to get the percentage composition of compounds or ions. So in the first step we need to get the molar mass, okay? So what are we going to do? As we already did before, we're going to list all the elements and all the subscripts or atoms that are present in the formula. So we have one phosphorus. For phosphorus, I have one phosphorus, and phosphorus molar mass is atomic mass is 30.973. And for oxygen, I have 3 times its molar mass, atomic mass, which is 15.999. This gives me the same, 30.973. And oxygen gives me 47.997. Okay, now when you add them all, this gives me 78.97 grams per mole. So far so good. It's a process that you already know, but what if I tell you I need to know the percentage composition of this? So you can do it in a single step too. The idea is that you divide this amount into the total and then you multiply by 100. Okay, so for phosphorus is going to be the total amount of phosphorus, which is 30.973 divided by the total, that is 78.97, and then you multiply times 100. Okay, when you do that, this gives you, okay, I'm gonna do the process once. 30.973 divided by 78.97. This number you multiply times 100, 39.22. You round it because the next number is 6. Okay, so you're gonna round it. 39.22%. Now I'm gonna get the same for oxygen. Oxygen will be this amount, the partial amount, 47.997 divided by 78.97 times 100. This gives me 60.78%. How can you be kind of sure if you did it right? If you add them, this plus that should give you 100. So let's see if it gives me 100. 100. So we can continue. Okay, you have to follow the same process here for aluminum sulfate. Okay, remember we have aluminum. I'm gonna do it here. Aluminum, we have 2 times its atomic mass, which is 26.981. This gives you something. We have then sulfur, we have 1 here times 3 outside times sulfur's mass, which is 32.064, equal oxygen is 4 inside, 3 outside, times its atomic mass, that is 15.999. Okay, now I'm going just to multiply. Okay, so I multiply everything. Now it's time for me to add. So I have this 53.96 plus 96.19 plus 191.99 rounded. I got 342.14. 342.14 grams per mole. Now, in order to get the percentage composition, remember this partial result divided by the total times 100. So for aluminum, I have 53.96 divided by the total 342.14 times 100. For sulfur, I have 96.19 divided by the total times 100. And for oxygen, I have 191.99 divided by the total times 100. You perform this in your calculator, and this should give you the following. Okay, for aluminum I got 15.77, for sulfur I got 28.11, and for oxygen I got 56.11. Now, in order to make sure that I kind of did the right process, I'm going to add them, and I should get 100. 100 or 99.99, 100.01, 02, all of them are allowed, are good answers, okay? So 15.77 plus 28.11 plus 56.11. Look, I got 99.99. It's not 100, but it's almost 100, so it is accurate, okay? So we can say that we did it right. Why does it occur? Most of it happens for rounding, but it's not a big deal, guys. It's good. Now we can say that this is almost 100, so we can say that it's kind of right. Okay. Now, what answer would have been wrong for example, if I got 95 points, whatever, for example? No, it's just so much difference. Or if you get, like, for example, 120%, that is wrong too. But 99.99, it's accurate, so you can allow it to yourself. Okay, let's do 2 more examples. Okay, I have barium nitrate, and I have to list all the elements, okay? So for barium, I have 1 barium times its atomic mass, that is, let's see, barium 137.34. I have nitrogen, that is 1 inside, 2 outside, times its atomic mass, that is 14.006, as you can see over here. And I have oxygen to be 2 inside, 2 outside, and its atomic mass, that is 15.999, equal. Now it's time for us to multiply. Okay, I'm gonna do this apart, and then I'll return into the video. Okay, so I got these results. Now I'm going to add them all. So I get 229.35 gram per mole. This is rounded. Okay, now it's asked for get the percentage composition. I'll do it here. Barium, nitrogen, oxygen. So for variance will be this partial amount divided by the total times 100 For nitrogen, this will be 28.012 divided by the total 229.35 times 100. And for oxygen, it's gonna be 63.996 divided by the total times 100. Okay, perform this in your calculator and I'll be back. Okay, so these are my individual percentages per every element: 59.88, 12.21, and 27.90. Sorry about this mess. So when I add them all, maybe I get 100, maybe 99.99. Let's see. 59.88 plus 12.21 plus 27.90. Oh, 99.99. I wish it was 100, but it's accurate, so I'm not gonna be angry. It's almost 100, so it's okay. Now let's do the last one. We have carbon, we have hydrogen, and we have oxygen. Okay, now we have 13 carbons, and carbon is the first one I have there, 12.011. Hydrogen, I have 18, and this is hydrogen's mass, 1.0079, equal, and oxygen is 2 times its mass, 15.999. So perform these calculations. Okay guys, sorry, I had a mistake there. So these are my partial amounts, so now I just have to add them: 156.14 plus 18.14 plus 31.998. I got 206.28 rounded. Now here I need to get my percentage composition, so the individual amounts divided by the total amounts. So for carbon is 156.14 divided by 206.28. For hydrogen is 18.14 divided by the same value. And for oxygen is 31.998 divided by 206.28. Perform this and let's get the percentages. Okay, so I just got the percentages: 75.69, 8.79%, and 15.51%. Now let's add everything. I just did and I got 99.99. So it's accurate, so we can say that it's okay. Thanks for watching guys, bye.